Good morning. In this case study, we're discussing about one essential component of engine assembly. The part name is called as connecting rod. Okay. So, what is the purpose of connecting rod? Is it to convert the transmission of power to the wheel. That is the main assembly of engine. Let's deformation. How to the deformation will be occur in connecting rod. Let's see how to modify this diagram into the answers. Then why this workbench? It is easy to understand where is the deformation will be occur under the load of 1000 newtons. Okay. So first of all, you're creating the solid modeling of connecting rod by using of SolidWorks. After creating the modeling, you have to save into the IGSC format. So why? Because we solve the IGS format. Why? Because means that is the answers. We have to import the diagram. Where is your drawing will be that. Okay, it's like a SolidWorks, Creo, Pro. So wherever you have to draw the diagram or modeling, you have to save the file format name is called as IGS. So that file we have to convert or import to the ANSYS workbench is more useful for our production learning. So in our students, we discussing about the connecting rod deformation by using under the 1000 Newton where various deformation will be occurring. The deformations are stress, strain and elastic deformation. Let's see on this topic in our students explanation. In the
Hello everyone, I am Jafar. Now we are going to see how to run axis as a SAT statement. We are taking the component, we are taking this component, this is a connecting rod, in a connecting rod of the system. We have to first save this. We have to first save the file as IGES, this format. Then we have to open a workbench in Ansys. In this Ansys, we can do many things. We can find how much stress is applied in this area and this part. We can do many of the things. We can find out how the material should be, and we can select the material property and everything. Pretty much everything we can do with this Ansys software. Now it's happening with the open. Now we are going to see the static structure. So that I'm going to select this one. Then for in this way, for everything, it should be like this tick mark, green color tick mark. Engineering data, we can keep it as the default one. And now we are going to select the geometry data. See, we have to import the geometry. We have to go to browse. Password. Start. We have to import the geometry. Now I'm going to select the browse. In that we have saved that file as robert.igs. This one we have to open. Then we have to double click the models tab. We have to wait for some time. It will take some time to go inside the model tab, and it will show the how we have to set up the file. Now it has been, we have to select this project. Wait, it is loading. Now it has came. We have to select the mesh. We can keep the mesh as any value we want. I'm going to select 3 as mesh value. The season. We can just cross reference this, everything is correct or not. Miss is okay. Now we should select in this one. We have to click the right click in mouse and insert. We have to click insert, and that we have to select force. How much force will be acting on which surface? Like that we have to click. In geometry, select the geometry and apply. Uh, we have to select the in a static structure. We have to select and we have to insert and we have to select the force, and it will come like this. In we have to select this geometry. Then we can choose this as the area where it is applying force. Then click apply. Then magnitude we can keep it as 1000 Newton. Then direction where it will be acting. You can keep it here. If you keep it here means it will come down. Apply. Then the force will act laterally. We can select many number of force. Now, for example, I am selecting only one type of force. In solution, we can go and check this deformation tool is there and strain tool. We can check many of things with this one. Then I am selecting this total deformation and in stress strain equivalent. Then I am going to click this solve button. Then it will solve. In total deformation, we can in equivalent deformation it only act on this hinges. In total deformation, we can see it is acting on this one, and later it is decreasing. That's it. This is only the ANSYS analysis process for static deformation and those things. This is what the SAR has taught us.